Hello everyone, myself Sumanta. In today's video, I will show you how to solve the Sudoku name whose parent cases 2, and then I will show you how I set and published this puzzle in Logic Master Germany some times back. And if you want to play the puzzle before I show you the solve, then follow the link given in the description of the video. So let's start with the rule first. The first rule is normal Sudoku rules apply, which means each of these row, each of this column, and each of this box will have the digit 1 to 9 without repeat. And then we have this blue diagonal line, so it says that there will be no repeated digits in the diagonal as well. So if this digit is 1, I will not have any 1 in this row and this column by normal Sudoku rule, and I will not have any 1 in this diagonal as well. Same thing is true for this other diagonal blue. So if this digit is 6, I will not have any more 6 in this diagonal as well. Next is these green lines. Along green lines, neighboring digits must differ by 5 or more. This is typical German whisper rule. So if this digit is 2, this digit has to be 5 difference from 2 or more. Then this can be 7, 8 or 9. But if this digit is 4, then I have only one option, this is 9. So that's typical German whisper rule. Next I have digits in each cage sum to the total given at the corner of the respective cages. This says that these three cells sum to 6, these three cells sum to 12, etc. etc. And gray squares contain even digit. So there is only one gray square here, and this cell has to be 2, 4, 6 or 8. And gray circles contain odd digits, so this digit has to be 1, 3, 5, 7 or 9. And so these are the rules. So first thing when I see this grid, the few things are I can see immediately. First thing is this 3 cell is summing to 6, so and they are within a box, so there will be no repeated digits in these 3 cells. So they have only one option, which is 1, 2, 3 in some order. This is true for this 7 cage as well, which is 1 to 4. This 8 cage in 3 cell must have a 1 in it. If we don't put a 1 in this these 3 cell, then the minimum will be 2, 3, 4, which will be 9. So I'll have a 1, definitely 1 in this 3 cell. Okay, so then next I have to go to German spread. I can see that this cell, from the clear cage perspective, it can be 1, 2, 3, 4 or 5. I cannot put a 6 here because then 1 here 7 and 2 here will be 9. So I cannot put a 6 here, and I cannot put a 5 here as well. If I put a 5 here, I can put a 5 by the clear cage rule, but I can't put a 5 here because of this green line. If I put a 5 here, this digit has to be 0 or 10, or 11, 12, more than 10. So that's not possible in a normal Sudoku. So I will not have any 5 here. Those who have played German Whisper Sudoku knows that if I have a small digit in one side of the German Whisper line, then the other side will have a high digit. It has to be either from 6, 7, 8 or 9. So you can think of it very easily. If we have a 1 here, this digit has to be at least 6 or more than 6. If we have a 4 here, this digit has to be 9. The same thing is true here. So this digit will be 6, 7, 8 or 9. This digit will be 6, 7, 8 or 9. And this digit can be high digit 6 with a 1 here. But if I put a 6 here and a 1 here, these two digits will be 2 and 3, and the sum will be 11, which is not possible. So this is again a low digit. It has to be from 1 to 3 and 4. And this digit has to be 6, 7, 8 or 9. 5 is not possible in German whisper. Now I can come to this box. There are 4 German whisper lines in this box. And I can, as I said, I cannot put a 5 in German whisper line. So the 5 in the central box will go here. So since I have made this puzzle, I know what is the trick I have used to make this puzzle. So let's directly go to the trick. And the trick has to do something with the set theory. Those who don't know set theory, I will suggest you to read a little bit about set theory, or you can follow the videos from Cracking the Cryptic YouTube channel where they have explained set theory in many videos. I'll not explain it here. Maybe I'll explain it in some other video. But the theory that goes as in any Sudoku grid, in this grid or in any Sudoku grid, this 4 cell, not 4 cell, this 16 cell, which I am marking green, has to be same as this 16 cell that I am marking gray. So that is true for any Sudoku grid. So if you don't know set theory, I will suggest you to read a little bit about set theory. But I will directly use the set theory here that this 16 green cell has to be same as the 16 gray cell, and I know the sum of these 16 cells in the green. And these 3 cell I know sum to 6, so the cage from the cages total I know that these 12 cell sum to 6, 7, 8, 9 is 30. And these 4 cells which are 6, 7, 8 or 9, suppose this digit is 6, I cannot put any more 6 in these 2 cells by normal Sudoku rule and this cell by the diagonal rule. So I cannot have a repeated 6. So actually this 4 cell also has to be different. And they are 6, 7, 8 and 9. So and that sums to 30 again. So the cages sum to 30, these 4 digits sum to 30. The total is 60. I know the sum of green cell has to be same as the sum of this gray cell as well. So if these green cells sum to 60, the gray cell will also sum to 60. And I know that these 3 cages are 36, this is 14 means 50. So this 4 cell which I am marking now will have the sum of 60 minus 50, that is 10. And and yeah, and then this post cell also has to be different, as I explained while explaining the rule that if I put a 1 here, I'll not have any more 1 in these 3 cells. So they have to be different digit, and for different digits summing to 10, there is only one option. They have to be 1, 2, 3, and 4. Okay, now these 3 I know that these 3 digits are 1, 2, 3. So this is this cell, so this cell has to be 4. I can remove 4 from here, 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 and here. Similarly, these 3 digits are 1 to 4, so this digit has to be 3, and I can remove 3 from here. Okay, I can remove 3 from here as well, from here as well. I know this 8 cage has a 1 in it, so this will have to be 2, this will be 1, and I can remove 1 and 2 from here, 1 and 2 from here as well. And 3, 4 in a German whisper line cannot go with 6 or 7. If I put a 3 here, the minimum here will be 8. So I can remove 6 and 7 from here, 6 and 7 from here, and that gives me 8, 9 pair. What do I mean by pair? That's 8, this is a 9. If that's a 9, this is 8. Because I cannot have repeated digits along the diagonal, as I have said in the starting. And the interesting point about these two cells is both these two cells is this cell. So suppose if this cell is 8, I will not have 8 in any of these cells, and both will become 9, which is not possible. So this cell cannot have 8 or 9 in it, so that will become 6 and 7. That is true here as well. So I can remove 8 and 9 from here. And this 8 cage, 8 cell, so this 8 sum, this cell cannot be 1, 2 or 5 anymore. And if I cannot put 1, 2 or 5 in a 8 cell cage, there are only 2 options of making 8 in 3 cell, 1, 2, 5 and 1, 3, 4. And 1 to 5 option is one for many reasons for this cell, as well as there is a 2 here. So I can make this as 1, 3, 4. And 9 cell cannot have a 1 in it, so there is only one option. That is 2, 3 and 4. Okay, now the thing to note is that maybe I can show with this one. These two column will have 2 ones, one in this column, one in this column. But if I see these cages, there is a 1 here, there is a 1 here. So the 2 1 that can go in these 2 column are already contained in these 2 cages. So this 6 cell will not have any more 1 in it. So the 1 will go in this box. Same thing is true for 4. So the 1 and the 4 will go here. And this cell, these cases into 14, so I will have a 9 moment. Same thing I can do here, and this 3 cell will be 2, 4, and 6. These 3 will be 2, 3, and 7. These 3 will be 1, 3, and 8. So this row, the 6 is in this box. These two cannot be 6 anymore. So the 6 will go in this side. Now this event digit is restricted. It cannot be 4. 6 sees that one, and it cannot be 2 because 2 is in this box. So there is only one option, which is 8. And this 8 sees this cell, so that must be 9. Okay, I will get many digits here with 2 be 8. 8 cannot go with the 4 in the dimensional line, so that must be 3. This will be 4. 4 is this cell, so that becomes a 4. This becomes 2. That's a 4. Can I go more? Yeah, that can be 1. That is 2. This 1 is this one, so that will be 2. That becomes 1. This is a 3. That becomes 1. This is a 3. 2 cannot go with 6, so that becomes 7. This becomes 6 by the whisper rule. Okay, this 8 in this row is in this box, so these two cannot be 8. This 8 is this one, so that becomes 8. I can do the same thing with 9 here. That is a 9. That's an 8. This became a 5, 7 pair. In this box, 5 and 7 cannot go here anymore, so this becomes a 5 and 7. That becomes a 6. This 6 in this cell, so that becomes a 6. This 5, 7 cannot go. 5 cannot go anywhere. Actually, these two are 6 and 9 by this row. That makes this a 5. That become a 9. These are 5 and 7, but this 7 is this cell, so that becomes 5. This is 7. Okay. Now if I see this row, this is an odd digit. It cannot be 1, 3, 5, or 7. So it has to be 9. Oh, these diagonals. This diagonal, if I see, if I see this diagonal, these two digits I can place because they cannot be 4, 7, 2, 5, 1, 6, 3. So they have to be 8 and 9. And this, by this diagonal, these two digits has to be 6 and 7. And 6 and 7 cannot go with 3 and 4, so that must be 1 and 2. This became 3 and 4. And the 4 of this row is gone here, so this cannot be 4 anymore. This cannot be 9 by this digit, so that becomes 1. I can remove 1 from this to cell. This 3, 4 is this cell as well. This 1, 2 is this means that cannot be 1. This cannot be 2. This 9 is this one, so that's a 6. This is a 9. These two, by looking at this row, I can say these two are 5 and 8. So there is no more 8 in this box, so this cell cannot be 8. So where is the 8 in this row? It is in this two cell. As this 8 is this one, so that becomes 8. Now this 6 cannot go here. This 6 is not a odd digit, so the 6 goes here. That makes this is 7. This is 6. 6 cannot go with 2, so that becomes 1 and 2. Now I can have a 3 here. This 3 is gone. Next what? This is a 5 or a 7. I have to put a 1 in this box. Cannot be here or there because of this 2 1. So 1 goes there. This 6 makes this a 6. This becomes 4. That's a 9. That's a 4. 9 is this cell. 8 and 9. 8 cannot go with 4 in the dimensional line, so that becomes 3. This becomes 4. This 8 is this cell. It becomes 5. 8, 7, 5, 7, 1. This can be 4 or 6 because of these two digits. and becomes 2. This 7 is same that one, that becomes 2, that's a 7. This is a 3 I think, that's a 2. This is a 5, no 2 here, no 1 here. These 3 digits from the row perspective is 6, 7 and 9. This cannot be 6 or 9, so that's a 7 because of these 2 digits. No 7 here. These 3 digits are from 2, 4 and 5. This cannot be 2 or a 4, so it's a 5. That makes this a 4, that's a 2. 4 means that's a 6, that's a 4. This 6 is that one, so that's a 9, that's a 6. I have to put a 1 in this box. These two ones is this 4 cell. This one is this one, so it becomes a 1 here. Now this digit by the column perspective is a 3 or 8, but this 3 is this one, so it becomes 8. That's a 3, that's an 8. I have to put a 9 in this box, it has only one place. 5, that makes this a 7, that's a 5. So this becomes 7 and this is a 3. So that's how to solve this Sudoku. So next I'll go to how did I set this Sudoku. For that I have to change the tab. I have to go to egg puzzle. I make my all my Sudoku, most of my Sudokus in egg puzzle. So let's go to egg puzzle. Welcome back again. So now I'll show how I have set this puzzle. Whenever I set a puzzle, the first thing I do is to look for an idea with which I want to make the puzzle. I'll explain uh, that part in my later videos or in details, but for this puzzle, the idea that I was trying to implement was is to do something with the set theory. As I have said while setting this video that this 16 cell that I am marking green has to be the same as the 16 cell that I am marking red. And this theory is set theory. Those who are familiar with set theory know this very easily. If you are not familiar with set theory, I'll ask you to read a little bit about set theory, or you may watch many videos by Cracking the Cryptic YouTube channel where they are explaining set theory very in many videos. So the point is this 16 cell has to be same as this red 16 cell. So I want to use this trick to make a Sudoku puzzle. So let's say if the easiest way of doing is suppose if I give the sum of these 16 phases, these 16 cells, let's say this 16 cell by giving a killer page, I give the sum of these 16, the sum of these 16 page to be 16, and I give the sum of this 12 cell to be 50. Then this 4 cell will sum to 10, and that one can find out by looking at the sum of these cases, and this 10 can have many possibilities. You can have 1, 1, 3, 5, or 1, 1, 4, 4, like that. So that will create a trick in the Greek. But when I was making this trick, it looks very easy to me. It's really people will find very easily that this is the case. And second thing is this 10 total has many ways of making it. 1144, 1135, as I said. So when I was making this puzzle, I thought this might be too easy for anyone to get. And second, this 10 cases, 10 total is not that much of restricted. So how to improvise upon this trick? For that, I was thinking of many ways, but then I thought if I give a diagonal, for example, if I put a extra rule that this diagonal and this diagonal cannot have repeated digit, then this 10 edge will be very 10 sum will be very constant. You cannot repeat 1 1 or 4 4 here. So that will force this 4 cell to be 1 2 3 4. So as I said while solving the Sudoku that will force this four cell to be 1, 2, 3. And that seems little bit nicer to me because so people will have to find out that it's not a very difficult trick, but people will be, means I feel this is much better than giving this repeated means 1133 1135 any possibility. I found this a little bit better. It's everyone's choice, whichever one you think will go good with you or with your. If you want to make it more hard, you can make it. If you want to make it easier, you can make it easier. So that one have to play around. But the next thing, what I think is, can I make these four cages a little bit interesting? Because uh, in that again, I was thinking of many ways, but like I was thinking that if I instead of four cage here, four cell cage here, if I give three cell cages, then what we'll do, then I don't know the sum of these four cells. Still the green cell sum to same as red cell, but now I don't know these four cell what they sum to. So people have to means so this I feel little bit nicer than giving a four cell cage. And what I can do since I don't know this sum, I can put a little more trick here. I can put a I can put a little bit of whisper here. For example, this line I can put whisper while make a different color here once it's not visible. So maybe let's change this highlight to blue so that I can see the green colors of the line. I think this is useful. So if I give whisper lines here and constrain the fact that these digits are small digit. So I don't know what is the total of the pages. I have not given the total yet, but I can constrain this four digit to be small digit. I'll do it later, but that will force this digit to be high digit. So that will be 6, 7, 8, 9. So this will give a little variation on the set theory. For those who will be solving the puzzle, will get a little bit of variation from the normal set theory. Normal set theory is there in many puzzles, so this will give the solver a little bit of variation from what we know from set theory. So and then if we make it 6, 7, 8, 9 by the diagonal rule and by the row and column, this four digit has to be different. So this four cell will have sum of 30, and these cages I'll make the sum to be 30, but I will do it later. I will not do it now. And this 4 I have to remember they sum to 50. So this 4 remaining 4 will become 10. And so now if you think from the solver's perspective, they have found out this 4 cell sum, this 4 cell sum, etc. etc. So once they have used this trick, I want to give them some reward that since you have used this trick, let's get a digit or one or two digit and see uh, if you, that will make people happy. Means if you do a trick and if you find it out something and then you get a digit, people it makes people happy. So let's make this total 6. That will do two purposes. First, it will keep this digit to small digit, and second, this 3 digit has to be, let's make it 6. So this digit will be small digit anyway, and this 3 digit will sum to 6. So people will find out there are 1, 2, 3, and that will give them a digit here 4. Same thing I can do on this side. That will help me to keep this digit small as well as, but I cannot have the same 6 sum because then both of them will be 4 and the diagonal rule will vanish. So let's make them 7. If I make them 7, 1, 2, 4, this digit will be 3. Now one can do some change this here. This will not be 3 4. This will not be 3 4. 1 to pair will remove 1 and 2 from here. Will remove 1 and 2 from here. This 3 4 pair will give me 89 here, 89 here. This 8 9 pair will give me 6 7 pair from this side. That will further force make this a 1 2 pair. Okay, so one will get up to there. So now what? So people, if you think from the solver's perspective, they have got this 4 and 3 and they have done this little bit of things here. So now what I want to do, this 3 digit you see, they have to be 589 just by the diagonal, and this 3 digit has to be 567. So this diagonal 3 digits contain a 5, this 3 digit contain a 5, the central one will be 5 and they will become 89. This will become 6 7. So since I have used whisper line, and this nicely became 6 7 and 8 9, I can use the whisper line again for two reasons. One, I don't have to use too many variables here, so I can use the same whisper again. And second, if I do that, I can this fourth digit, which is supposed to be 1 2 3 4, I can pair them as 1 2. First of all, this has many points. First, this will look my grid a little bit better, and this 1 2 pair will help me at the end to disambiguate these three cell cases, because right now disambiguating this will be problem because they are one-sided and three cell cell. So if I make them 1 2, that will remove 1 2 from here, 1 2 from here, 3 4. This 3 4 will remove 3 from here, 3 4, 3 4 from here. So by giving this whisper a little bit, I don't have to use too many tricks. People will get the 5 here, and that will help me towards the end disambiguating these three cell cases. And now what? Now next is, so people will come up to here. The solver has come up to here. Now the next thing what I like is I don't want to make it too much pencil mark in grid. So people have got 1 2 3 4. They have made some pencil mark. Now I want to I want to disambiguate these things. This whatever the marking that I did, I want to disambiguate that so that I get some digit uh, and uh, so that people feel they are moving in some solving direction. So, and for that, what I first thought is, let's give this sketch. I cannot use 6 and 7 anymore, but I have to keep this cell as a low digit. So, if I give a 8 total here, that will be nice. That will make this a 1 3 4 sum, because this digit is not 1 2 or 5. So, this sum will be 1 3 4. That will disambiguate my these two cells. And since I got a 1, I can use a little bit trickier and make this a 9 cage. Because since 1 is not there, and if I make this a 9 cage, I'll have only one option, and I can do that by making this a 9 cage. Okay, so I got a little more disambiguation. Now the sum of these cages becomes 6, 7, 8, 9, that is 30, and this 6, 7, 8, 9, 30 is 60. So I have to remember that this cell sum to 50. I have not given the sum yet. So, but once I do make this 6, 7, 8, 9, I can see that this 2 and 4 has to live in this cell. So I have a choice to put the third digit here. I can put 6, 7, 8, 9, whichever I want. Similarly, in this cell I have 2 and 3. So I can give the third digit and give a sum here. Same thing goes here, and as well as here I think 1 and 3. Yes. So so I have a choice to put the third digit here, because I can give the sum, let's say 10 or not 10, let's say 11. Then this digit will be 5, third digit. Same thing goes here, but I have to remove the total has to sum to 50. So next thing, how to disambiguate this. There are already many pencil marks, so let's try to disambiguate in some way. one thing I saw that if I give this digit to be something, I can see this digit and this in the bit. Similarly, I can give this digit or this digit something. But this digit, if I make it a even digit, I saw that it has two options only, 2 and 4. So it will have only 6 and 8. These two will be the option. But again, then I have to disambiguate whether it's a 6 or an 8. Then I saw this case. If I give this case to be 2, 4 and 6, then that will plonk the 6 in this direction and will make this an 8. And that will help me to disambiguate the grid in much better way. So you can think of many other ways of disambiguate whichever you like, but I like that this is a easy and a nicer way of disambiguating the grid. So what I did is I use another constant and event digit, put it there and make this sum to be curved. And once I put that's an 8, that gives 9, 8 here, and 9, 8, oh sorry, yeah, that's fine, 8 cannot go with 4, so that becomes 3, that becomes 4. This 3 is this cell and then becomes 3. I have already shown this while solving the video, so I will just quickly try to fill in the grid. So 2 has to go with this 7, and 6. Okay, so I have gone up to, or I have come up to here, and then next what? So then I have to give these three. So rest of the thing I have to disable here. So what I saw that this 8 was, if I put this third digit as 8, I will get a little more disambiguation because this 8 will plunge 8 here, and next will be uh, and then I saw there is only one 9 in the bit. I have two 8, two 7, three 8s, one 6, but 9 at least I have two 6. I have four 8s, but 7 and 9 are a little bit. I don't have that much of information about 7 and 9. So I thought if I give this cell as one more 9, I may get some hints about the 9 in the bit. So this 9 and this 9 will give me a 9 here, and then uh, this 8 will be here. I'll get a 5 7 pair here. So I'll be able to solver or anyone will feel like they're progressing. This 5 7 will go there to make this a 6, and then this 5 7 that will make this a 6 9 pair. I'll get a 5 here. So since I want to make this but not too hard, this 6 will 6. See this one, that will become a 9. Automatically this 3 becomes 2 3 7. So I can beat the sum, which is 12 again. This is 12. This is 14. Is now if I see the sum, 36 plus 14 is 50. So everything is fine. So the next thing of this puzzle is not. So what I see that I have already disambiguated a lot of the grid and many position are pencil mark. At this point I wanted to solve this Sudoku with a minimum constant. I don't want to use any other new constant. This puzzle is already looking good. It's looking good aesthetically or anyway everything. It's not very crowded. These cages are in a nice pattern, so everything is looking fine. So I don't want to make it too much crowded here. Obviously, like for example, I can use a thermo here, I can use a killer cage here, many things I can do, but I wanted to make it, at this point, I wanted to make it as clean as possible. And what I see that if I tried many ways, I'll not go to the all of them, but if I see that if I keep this to odd digit, the whole grid was sort of disambiguated. If I give this to the odd digit, This odd digit is little bit restricted. It cannot be for this 7 will make this 5 and a 7. So if you see, if I make this odd digit, I'll get this digit. Then 9 and 3 4 will make disaggregate this part. So at this point, my intention is not to make it too much crowded. Without making it too much crowded, can I get to the solution? So this one to pair, as I said, this one to pair will help me towards the end disaggregating things if they are helping, and then this will become I think this 9 will see that on. So at this point, don't want to make the puzzle too crowded and want to go to a solution. So this 5 8 will remove 8 from this. So I'll have a 8 here. This 8 will see this cell. So I'll get a 8 there. Now this 6 will go there, and as you see that this 6 will disintegrate this part. 7 6 1 2, and this further, can you go further? Yes, we can put a 6 here, we can put a 1 here, and this will be 4, I think. Yes, and that will disintegrate this 9 and 4. This 9 will see this 8 and 9. German whisper will help me to sort this out, and so at this point I don't want to make it too much difficult or too much crowded. So I have to go in a very easy and linear way to the solve. This 8 will disintegrate this 5 and 8. 5 will give me 7 here, 2 here, 7 here, and this will be 7 and 2 is gone, so that will be 3, 2, 8, was not 8, 6, 7, 8, 1, 2, 3, 3 I think, 4, 5, that 5 will see the 7 and the 5 here, and then if I go this one or this one, I think this 6, 7, 9, there is 6, 9 here, so that will be 7, this will be a 6, 9 here, 9 here, this is not a 8 anymore, and then this at from 2, 4, 5, which will give me a 4 here, this will be 2, 5 here. So yeah, so that's, I think this will go. Once you know from the solution that this does go till the end. So this 6 will see that. Out 9, yes, it's the 9 here. This 3, that's a 5, I think. 2, 4, 2, 5, 1, 3, 8. That's a 1, I think. And that 3 will make that say 8. This 3 I have shown while solving, so that's a 3, that's 8. This 5 is 7 and 5. I have a 3 here and a 7 here. So this does go till the end. So, uh, so in short, first thing what I tried is to implement an idea. And getting an idea or implementing it sometimes takes time. You have to play a lot of Sudoku, you have to watch a lot of Sudoku solution. Then you get uh, many ideas that helps you to make puzzle. So I'll suggest, if you want to make your own puzzle, try solving a lot of puzzle, tries to see how others are implementing their ideas into the puzzle, and when you solve a lot of puzzle and see others' ideas into the new puzzle, you start getting good ideas to make your own puzzle. And 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 next thing what I'll see, I mean at this point, what I'll do, I'll remove all the digits here. And next thing what I'll do is I'll try to see, did I implement my idea in a better way. Of course the grid looks better, that's I can see. At this point the grid is looking very nice, and nice to me. I don't know whether at least it's looking nice to me. and and uh, and I have not crowded it too much, and the puzzle will not be that much difficult to solve. Those who are familiar with subsidy will find it very easy and nice. So I wanted to keep this puzzle in a two-star category in the Master Germany, and that fits well. The next thing what I will do is I'll try to solve it. Once I make the puzzle, I'll try to solve and see does that make me happy while solving the puzzle. If I see that while solving the puzzle I am feeling happy and everything's going very nicely, there is no means uh, means in this puzzle there is no very difficulty or something, and if it matches everything with the flow, everything, then I will go ahead and publish this puzzle. If you want, you can take a help from your friends and do a test solve and see if they are also enjoying solving the puzzle. When everything is nice, you can go ahead and publish it to the solver. And at this point, again, I will say I will try to solve this puzzle and try to solve it maybe one or two times and see does it make me happy while solving the puzzle. If it does, then I will go ahead and put it in any appropriate place. So I think this is my first video on on making and solving Sudoku. Hope you liked it. I will explain all these many other tricks that I use or that goes with solving and setting Sudoku in my next videos. I will continue this series for some time and hope to see you soon. See you again in my next video. And till then, have a good time. Bye.